Hello and welcome to the Innovate-A-Thon Discussion,
where we cover everything going on in the world of innovation, creativity, workforce advancement, entrepreneurial thinking, and enabling the next generation to do good in the world. We'll explore interesting topics with mentors, students, and innovators who are shaping the future. So I'm happy again today to have my colleagues, Natalie and Jim, on the podcast with me. So today we'll be going into another tool set that's used in our Innovate-A-Thon program, and that is TRL, Technology Readiness Level. So hey Jim, hey Natalie, happy to have you on again today, and we're going to just dive into what is Technology Readiness Level, how to use it, how does it get you into a position to understand where you are, maybe where you've been, where you want to go, and how people can kind of use it in their innovation journey. So Jim, I'll kind of just hand it over to you to give us a little bit of background, and then we'll get into it. So
okay, I'd like to say everything has a beginning, a middle, and an end. Like this podcast, we have a beginning. We're now sort of in the middle, and we're going to have an end eventually here. But the same thing when developing a new innovation, there's the beginning stage, there's the middle stage, there's the not so much the end stage that it is when it's implemented, when it's put to use up there. So I've got an idea. Well, that's a long way from going and selling it or solving a problem from it. So when people have ideas, they might make sketches, jot some things down. We might share those sketches with us. And eventually we might say, hey, this looks like there's something here. Let's start putting it together and see what we come up with. So there's an old-fashioned term called a breadboard. Engineers use that term. We're going to make a breadboard model of this. And, I really feel dated with gray hair here. When they say breadboard, at one time in history, they really literally meant a breadboard. The board that you cut bread on, it's nice and smooth, and it's a nice piece of wood. And it's something that engineers would use, and they'd build it on that breadboard because the board would hold all the pieces together. Obviously, that doesn't work for every kind of prototype you would have, but that terminology just sort of stuck in there. So sketches and breadboard. And then, hey, let's show we're smart and use the Greek alphabet. We got alpha version here. And alpha, like the first version of something. And, generally when an engineer said, I have an alpha version, all the other folks would know, well, if you have an alpha, it's really pretty rough around the edges. It's crude. It's built on a piece of wood. We can show it to friendly people that aren't going to laugh at our alpha because it's pretty ugly. In my engineering days, I could show you pictures. I'm not going to, but I could show you pictures of some of my alphas, and they were really ugly. Now, they turned into nice products, but the early versions were really pretty coarse. And you generally wouldn't show alpha versions outside of the lab. And now, hey, this is working. We got sort of the bugs worked out of it. Now let's build the next version and call that beta, the second letter of the Greek alphabet. It's a beta version, and it's a little nicer. It looks a little friendlier, and you might show that to people outside your comfort zone here to see what they thought about it. And then eventually into production, the early versions of products, they call it 0.1. It's not quite a 1.0. It's just early stages, and you're getting the production issues taken care of so you can actually build a number of the units. And then finally 1.0. So some of the more famous 1.0s, Microsoft operating system years ago, they had a 1.0, and it was really bad. I mean, they were selling it, and it worked on early stage computers, but it really wasn't until Microsoft had version 3.2 of Microsoft operating software that it was stable, and people actually stood up and go, oh, hey, that looks pretty good. It's just sort of how products evolve.
Yep.
Now, the government got involved in saying, well, that's all kind of informal, alpha, beta, 0.1 and all of that. So they said, let's put together a more formalized system, technology readiness levels. So when government projects are going through and starting at the early stage, TRL 0 is idea stage. TRL 9 means it's rocking and rolling and it's out there. So when you're talking to other people in the network, you could say, well, this particular project is at a TRL 5 or it's a TRL 7, and people would know exactly what that meant. And I think, Natalie, you were going to explain those numbers a bit.
Yeah, so I'll touch on TRL stages 0 through 9. So the first stage, stage 0, let's say, because the first stage is basic research, but stage 0 is kind of like the idea and the general concept, like defining the problem that's there to solve and identifying like the innovation's purpose, like why does this concept matter to society, economy, or the environment. And then we see the next stage, which is stage 1, which is your basic research. There you're kind of like conducting a lit review or market research to kind of see what existing solutions are out there and the limitations that they have already, just so you're getting an idea of like what it is that is out there. And then you kind of want to identify the gap in the knowledge that's already out there. The next stage, which is stage 2, is concept formulation, kind of where you're translating the research into concepts or approaches for your problem. So this one, like you're brainstorming more, doing a little bit more work, kind of getting your ideas out there, working with groups maybe or independently just to kind of see how you can turn your initial idea into a concept. And then the next one is TRL stage 3. That's your proof of concept stage. That's when you're kind of testing the feasibility of the concept through like experiments or prototypes and discussing the challenges of testing in real world environments. So you could create like a basic prototype on paper or just simple materials, like a student created a clipper thing, and that was just like a very basic prototype. It wasn't super in depth. The next one is TRL 4, prototype testing in a limited environment. So that would be more testing in like testing the feasibility of the invention and seeing if it can like hold up against things, like if it's like actually a valid prototype. And then the next one is validating it in the environment. So you're kind of testing it in an operational environment, not yet at full scale. You're just seeing if it can resemble like some of the real world applications that are out there that you've already researched. And it can kind of just verify if it can work under realistic conditions. The next one is TRL stage 6, the validity of it within industry and how it can hold up in economic validity as well. So here you're kind of seeing if it's ready for scaling and if it can be integrated into industry standards. And you're seeing if like the end users can actually use it and if the cost benefit analysis like shows that it can be commercially viable and if it can be produced like affordably and effectively, to kind of see if it can be thrown to the next stage, which is stage 7, and that's scalable demonstration system. So here it's almost demonstrated at a full scale with you checking if it could work in like real world operational environments. You're validating it at a much larger scale, almost to the commercial or operational setting, when you're testing for scalability, reliability, performance, and consistency under a variety of different conditions. The next stage is stage 8, and we have the replicable system in production with commercial team. So this is at a much higher level. It's a full-scale production with a clear path to market so that you can see like the production process and if it's good enough to if you can take it to manufacturing. And here you're like getting it manufactured, you're getting it marketed, customer support, distributed, all that good stuff. And the last TRL is TRL 9, and that's commercial deployment. So here it's fully deployed, it's in its target environment, it's being sold, there's widespread use of it, there's benefits to the users, and you're kind of trying to see like improvements that you can make to it based on the real world feedback and application of it. And those are the 0 through 9 levels.
Awesome.
You know, one of the call it a product that we're seeing a lot of SpaceX, for example. In the last 5 years here, it's gone from TRL 5 to TRL 9, and it's every once in a while you're wondering, is it really at 9? Is it really stable up there? Because one blows up. The other day, one kind of had an issue up there, and that's just sort of the nature of the space type programs and things up there. But it's interesting to look at some of the technology and say, where is this on a TRL level? Is it 7, 8, 9? We usually don't see things 0, 1, 2, 3, and because they're behind closed doors in the factory and in the lab and things like that. But
yeah, I think I've used TRL a little bit, in my past, and more so I've seen all of these different stages, and everybody groups them differently. Like they can kind of group them all these do kind of happen, like whether you like it or not. Like most of all these stages start to happen, and it's an iteration cycle that's kind of happening like inside each of them also. But I think I was talking with Natalie, coming from my background with aerospace. These are mentioned too, and like I didn't work for NASA. I worked for a commercial side of aerospace, but they bucket them into like initial, PDR, CDR, FAI, but they're all in the same spectrum. Like they all go through the same thing. So like, and a lot of the times too, it's funny, the FAI and production, they get crisscrossed a lot, because it's, you think your first article is good, and you go out and it seems like it's a replicable system, you know, and you think you're ready to go, and then you might backtrack, or you might be further than you think, and then your first article actually becomes your version 1. And so there's like this kind of area in there. It's still succinct, but that launch like into commercial side of things. And and what I called it was first article inspection. So it's like a full replicable system. It's all laid out. I worked in aircraft interiors first part of my career, so they would have all of the seats and configurations all laid out in a demonstration area. Everything's functional, everything's working. You start working out all those last little things that aren't, and doing, you know, change orders and things to get all of that fixed. And then if it gets a thumbs up, they go over there and they christen it like, yep, this is version 1. Everything works. It can go on the airplane. If it's not working, all of that will be redone, and then the version 1 will be a whole new setup and system. But yeah, so, and it really is, it comes down to what industry, what financial restraints you have, and you know what you promise to deliver on and what you actually deliver on. So that's the fun part about that, the end of it. And you know, that's that portion. But in Innovate-A-Thon program, you know, we get the fun portion. I don't know if you want to call it the fun portion, but it's the portion where the ideation starts to happen, you know, and we cover a lot more of, you know, 0 to 3 to 4 spectrum. And that's really in that research side of really getting all the bases for how you can get to that spot in the future. And it's great though, you know, you can't just be in the ideation phase and doing research and keeping your head down and not looking at where you need to go. You still have that development plan out, or at least an idea of how you're going to stage it out, you know, to test it further. So that's the great part about this. It's a long scale, but it gives you that opportunity to have, you know, milestones, things that you hit, and progressively work towards something. And then you have NASA, which is on the extreme, is which they have to have a stage gate deliverable at the end of that TRL, so they can go to the next one and prove out each of those steps that they work until they get to the spot where it's replicable system that it can be deployed. So yeah, there's extreme ends, and NASA is probably one of the more extreme. So yeah.
Well, NASA is a good example where there's a serious checklist at the end of each one of those TRLs.
Yes.
You don't call it the next level until you've actually gone through and proven that.
Yeah, exactly.
I think what the different updates remind me of is like Apple iOS 10.1.2, 10.1.3, 10.1.4, like all the different versions.
Sure.
Like, oh shoot, we found a bug, this is where we need to fix. And that's kind of what the TRL makes you realize, like, oh shoot, I need to go back to this step and change this. Go back to this step and change this.
Yeah. And then having got a hold of beta test software, it's the best thing if you ever get a hold of it, because then you can have input in it too. So that's usually, like Jim said, you have kind of that alpha step where that's usually, it's kind of behind closed doors, and you're not quite ready to, like, you know, go out and give it to a whole bunch of people yet. It's still kind of controlled. But as soon as they get to beta, then they want market, like that last market input of like, and that's why they call them beta testers, right? Beta testers.
Right.
That stage where you go out, like, okay, we're at this spot, we need to get this feedback and get it incorporated so we can move to the next step. And so you send it out to a base of people, and then they give you that feedback. I've been a part of that before, and it's fun. It's, you know, you're in there and it's like, okay, it mostly works, but then you run into something and there's some whole feature that you're like, why is this not here? Like, this should be here, like, because I, you know, X, Y, and Z reasons, like, I need to be able to use it as a user of this. And then they take that and they'll incorporate it. And if it's feasible, you know, in their team structure, they'll actually take that and incorporate it. And so I've been a part of that process too, and it's a fun process. And yeah, I'll go more specific too, just because I like to give stories. Autodesk is a company. They're one of the first like CAD software companies, and they've been doing different types of CAD systems over the year that are different target markets. And yeah, one use case is, I really liked their model. They switched to kind of the maker model when the maker movement kind of came out, and they offered this new Fusion 360 software. There's still a hobbyist version you can get of it too. That's free. And so when they were first releasing this new module called generative design, and they started doing all this AI stuff, this was even back 10 years ago, 10 plus years ago. And I was fortunate enough, I bothered them enough they kept saying they're going to release this. And they're like, oh, you just want the beta of it? I'm like, oh yes. So give it to me. Like, let me look at it, because I could see the potential in it. And that first interaction. But really, you have to have those steps before, because if you don't have enough beta tester feedback, there's going to be something that might be a no-go when you go into market. Yeah. All of a sudden you realize like 2/3 plus of your user base doesn't have something, and then they get frustrated, they don't buy, and then your company goes the other way, the way of the dodo. So it's fun. And I think, like I said, Innovate-A-Thon, we are in that first stages more so of the formulation and the beginnings of things, but it's at least understanding that it has to get to that point, right? You have to work your way around our 4 stages, still have ideation and the creative part of it, and get all that into the process. But then it's that narrowing in towards the left brain, more analytical, more like this has to be implemented eventually in a full production scale at some point. And so you have to keep thinking about that as you're progressively going through steps and refining and getting to a spot where the rubber is going to meet the road, and you're going to have to be super left brain to make things work. So, yeah.
It's fun to, like you said, the early stages of here's an issue, what can we do to make it better? The one I got a big kick out of, I'm a coffee drinker, and what don't I like about drinking coffee? Well, it gets cold after a while in that mug. Well, look at this. This is a mug. I'm going to turn it so you can see it here. You see the little light on there?
Oh, wow.
This mug charges and keeps my coffee warm. It has a little computer inside of it to keep the coffee warm and identify what level of heat the coffee's at.
Can you throw that in the dishwasher?
Can't put it in a dishwasher. That's the next version. This is only version 1.0.
It's the alpha test.
It can probably go in the dishwasher. So I hand wash it, and it says not to. I would show you underneath here. It's got a little.
But you'd spill it all.
A charger where you sit it in. Yeah, but I would spill my coffee on there. But, there's just like, wow, who'd have thunk it? Keep the coffee warm with a computer control.
That's great.
Yep. And I think too, it's fun to think about. We can imagine all the way the ideation of like they identified a user need and the amount of people that drink coffee and the amount of people that drink cold coffee throughout the day, and really, formulating a use case, behind that, like use case inspired, like, and then you're working towards that spot where, imagining those first prototypes, are rinky dink, like just getting an idea, and really crude, like engineering, too, is like you're hooking like a very crude heating element to the bottom of a cup and just doing like real simple, just like
burn yourself in the process.
Yeah. Don't hurt yourself during the first stages, but run some tests so that you can understand, that, okay.
I'm sure they'll have something the next tester where it's like, it is dishwasher safe. Wow.
But that too. Yeah. And it's the same thing, that went to production, but it doesn't stop there. You still try to keep some of those elements of that process. Is if you have a good company and a good team, that you bring those back in the iterations and the version updates and things that happen after. Mm-hmm. So, yeah.
Well, my coffee mug has an app too. So on the app, you can tell it what temperature you want the coffee at. I mean, isn't that like overkill?
That's crazy. That's
Right.
absolutely crazy. What temperature do you put it at?
Whatever it came at. I haven't played with the app very much yet. I need to do that one of these days.
But yeah, right. It's a simple enough user experience where the defaults probably work, and then
Yeah,
it's a
right,
system that you
exactly.
use, and you're happy, and your coffee stays warm.
Right.
And
You don't get burned?
yes, yeah.
Yeah, I guess, yeah.
Dang, that's crazy.
Very cool. Yeah, so I think too, one of the last things I kind of wanted to touch on again too is because we talked about Pastures Quadrant last time too, when we were talking about tool sets and kind of that same like framing around. I think I was looking through some things too, and like Thomas Edison, you know, kind of lived a lot more in the first parts of the TRL until he was very ready to go to the later steps, and you know, he tested unclaimed 6,000 iterations of the filament and things like that we discussed last time. So you know, you can be anywhere in that, and you can recognize where you are in TRL, but you could spend years on a certain part of the TRL too, if there is that cycle that happens where you're doing a lot of tests, like you're doing a lot of validation, you're a lot of tests. If you have a lot of time, money, and resources, you can stay in probably one spot, but then getting to a spot where you can progress forward and keep moving. So yeah, just being inspired that it's a journey. I think we talked about maybe that a little bit last time. And everybody starts at the beginning. Like you're gonna crude, can't tell you how many times met with somebody that was entrepreneurial, like, oh, you have an idea, and like, yeah, I sketched this on a napkin last night. I'm like, okay, we're definitely
Like,
we're pretty far forward. We're right here. We're like zero. You sketch it, you have a decent idea, you maybe have a little bit of background, and there's going to be lots of steps that you have to go through to work through the TRL type scale to get you to a spot where it is feasible and it can be implemented. So,
and I think that's like something very important. Like there are going to be those failure moments. Like Edison, he tested like 6,000 or 10,000 different filaments to get like the light bulb actually working, actually correct. And Colonel Sanders, he he's just funny. Okay, I like Colonel Sanders, but he tried like 1,000 different recipes before he finally got like the final approval and the final say that like, oh, this is a good recipe. So like, you just got to keep on keeping on, even when you're like, man, this isn't a good idea, this is gonna fail, or man, I'm stuck at this level or this step. Like, just keep on trying, keep on pushing, and eventually you'll have some success.
Well, I think that was great discussion. Thanks, Natalie and Jim, for talking through TRL today. I hope that everybody got something out of this. You can go out and start using TRL, and your ideation, innovation, impact model, and start going out and making things happen. Thank you so much for joining us today, and we hope to see you again on another episode of the Innovate-A-Thon podcast. Have a great day, everyone. Thanks.